If you follow our channel or astronomy developments regularly, you probably already know that the James Webb Space Telescope, JWST, is set to revolutionize our view of the universe. In September 2022, NASA released a new image of Neptune that caused a significant stir. It was the best view of this icy planet in over 30 years. Neptune, one of the least explored and most mysterious planets in the solar system, has always fascinated scientists. Let's dive into the secrets of this enigmatic blue giant. Neptune, the eighth planet from the Sun, is the last in the solar system since Pluto's reclassification as a dwarf planet in 2006. It is the fourth largest planet by diameter, the third most massive, and the densest among the giant planets. It has about 17 times the mass of Earth and is slightly more massive than its twin, Uranus. Composed mainly of gases, liquids, and ice, Neptune is classified as an ice giant. Orbiting at a distance of 2.8 billion miles from the Sun, Neptune takes 164.8 Earth years to complete one orbit. It was the first planet discovered through mathematical calculations, with its existence confirmed in 1846 by German astronomer Johann Gottfried Galle, based on predictions by British mathematician John Couch-Adams and French astronomer Urbain Le Verrier. Neptune's trademark blue color comes from methane gas, which absorbs red and infrared light, giving the planet its characteristic hue. Named after the Roman god of the sea, Neptune's atmospheric phenomena and surface features continue to intrigue researchers. Neptune is one of the least studied planets, but the little data we have reveals dramatic atmospheric changes over time. Observations from the past few decades show that Neptune's storms and winds, which can reach up to 1,345 miles per hour, are far more intense than those on any other planet. In 1989, Voyager 2 captured the first close-up images of Neptune, revealing a massive storm called the Great Dark Spot in its southern hemisphere. This whirlwind, similar to Jupiter's Great Red Spot, mysteriously disappeared by 1994 when observed by the Hubble Space Telescope. A new dark spot emerged in the northern hemisphere, showing that Neptune's storms are far more transient than Jupiter's. While Jupiter's storm has lasted centuries, Neptune's storms typically dissipate within a few years. In 2020, the Hubble telescope observed an unusual storm wider than the Earth's Atlantic Ocean. Initially drifting southward, a trajectory that would typically cause storms to dissipate, this vortex unexpectedly changed direction, heading back north. Such erratic behavior is unprecedented and remains a mystery to scientists. The JWST captured an unparalleled image of Neptune in September 2022 using its near-infrared camera, NIRCam. Unlike previous images, where Neptune appeared blue, the new image shows the planet in darker shades, highlighting methane gas that absorbs infrared light. Bright spots and streaks are visible as clouds of methane ice, reflecting sunlight and appearing almost white. For the first time, Neptune's faint ring system was clearly visible. These rings, composed of ice crystals, were first observed by Voyager 2 but were barely discernible due to limitations in imaging technology. The JWST's advanced capabilities have provided astronomers with a much clearer view, revealing intricate details of Neptune's dynamic atmosphere. One of the highlights of the JWST's image is Triton, Neptune's largest moon. Appearing as a bright, blue-green point of light, Triton outshines Neptune itself due to its reflective icy surface. This moon, roughly the size of Earth's moon, orbits Neptune in a highly elliptical path. Scientists hypothesized that Triton was once a Kuiper belt object captured by Neptune's gravity. Triton is particularly intriguing because it exhibits signs of ice volcanism, and beneath its icy crust, there might be a liquid ocean. This makes it a compelling candidate for future exploration, with the potential to discover microbial life. Despite receiving minimal sunlight, Neptune has an active climate. Its atmosphere contains methane, ammonia, and water, contributing to intense geological processes. Unlike other planets, Neptune radiates nearly 3 times as much energy as it receives from the Sun. This internal heat likely comes from gravitational compression and possible interactions with Triton. Neptune's seasons are also peculiar. A single season lasts 40 Earth years due to the planet's long orbital period. Yet, the planet rotates quickly on its axis, resulting in days that are only 16 hours long. These dynamics drive some of the strongest winds and storms in the solar system. Scientists are puzzled by Neptune's unpredictable atmospheric behaviors. In 2018, researchers observed significant cooling in its atmosphere, followed by a sudden temperature rise at the South Pole. Additionally, the planet's chemical composition seems to change over time, indicating internal processes that are not yet understood. Some theorize that these changes could be linked to gravitational interactions with Triton or other yet undiscovered mechanisms. One hypothesis suggests that Neptune's internal heat may support a subsurface ocean. This idea opens up the possibility of life, as we've found extremophiles thriving in extreme environments on Earth. Although speculative, the presence of life in Neptune's depths cannot be entirely ruled out. Beyond Neptune lies the hypothesized Planet X, or Planet 9. Astronomical observations of distant objects in the solar system suggest the gravitational influence of a large, yet unseen planet. If it exists, Planet X's highly eccentric orbit could keep it hidden, with an orbital period stretching up to 1,000 years. The JWST's advanced capabilities might one day help confirm its existence. Neptune remains a priority for future exploration. A dedicated probe, similar to NASA's Cassini mission to Saturn, could provide invaluable data about the planet's atmosphere, rings, and moons. Such a mission could also investigate Triton's potential subsurface ocean and explore the Kuiper Belt objects beyond Neptune. The James Webb Space Telescope has opened a new chapter in our understanding of Neptune. Its high-resolution images provide unparalleled insights into the planet's composition, weather patterns, and ring system. Scientists are now better equipped to study this distant ice giant and its moons, paving the way for groundbreaking discoveries in the years to come. Neptune, once considered a barren and desolate world, has proven to be far more dynamic and complex. As we continue to unravel its secrets, the possibility of life and the mysteries of its internal processes remind us of the endless wonders of our solar system. The icy giant at the edge of our planetary neighborhood still holds many surprises, and with the JWST, we're just beginning to uncover them. Neptune, the distant sentinel of our solar system, continues to captivate astronomers and scientists alike with its enigmatic features and dynamic atmosphere. As the James Webb Space Telescope, JWST, provides unprecedented clarity and detail, the icy giant emerges not just as a cold, remote planet but as a complex world with untold mysteries waiting to be solved. One of Neptune's defining characteristics is its fierce and unpredictable weather. The planet's atmosphere, composed primarily of hydrogen, helium, and methane, experiences the fastest winds recorded in the solar system, reaching astonishing speeds of up to 1,345 miles per hour. These violent winds drive immense storms, such as the Great Dark Spot observed by Voyager 2 in 1989. Unlike Jupiter's Great Red Spot, which has persisted for centuries, Neptune's storms appear and dissipate within a few years. This transient nature raises questions about the mechanisms driving these systems and the planet's internal energy source. The JWST's high-resolution imaging has not only sharpened our understanding of Neptune but has also brought its elusive ring system into the spotlight. Neptune's rings, composed of icy particles and interspersed with clumps of denser material, were first glimpsed by Voyager 2 but remained faint and undefined. The JWST's near-infrared camera, NIRCam, has illuminated these rings, revealing their structure and composition in stunning detail. This breakthrough allows scientists to study the processes shaping these rings and their interaction with Neptune's moons and magnetosphere. Among Neptune's moons, Triton stands out as a celestial oddity. Unlike other moons in the solar system, Triton orbits its planet in a retrograde motion opposite to Neptune's rotation. This unusual orbit suggests that Triton was not formed alongside Neptune but was likely a Kuiper Belt object captured by the planet's gravity. Triton's reflective icy surface, coupled with evidence of cryovolcanism, hints at a dynamic internal structure. The possibility of a subsurface ocean beneath its frozen crust makes Triton a compelling target for astrobiological studies, as such an environment could harbor microbial life. The dynamic interplay between Neptune and Triton extends to the planet's internal heat generation. Neptune emits nearly 3 times as much energy as it absorbs from the Sun, a phenomenon attributed to gravitational compression, radioactive decay, and possibly tidal interactions with Triton. This internal heat contributes to Neptune's active climate and volatile atmospheric conditions, as observed by the sudden temperature fluctuations recorded in recent years. These variations challenge existing models of planetary atmospheres and highlight the need for more detailed studies. The JWST has undoubtedly ushered in a new era of exploration for Neptune and its surrounding environment. By providing unparalleled insights into the planet's weather patterns, ring system, and moons, it has laid the groundwork for future discoveries. Neptune, once relegated to the fringes of planetary science, now stands as a vibrant and dynamic world full of scientific potential. As humanity's gaze extends further into the cosmos, the icy giant reminds us of the boundless mysteries that await beyond the edges of our planetary neighborhood. Thanks for watching Space Lab. Subscribe for more cosmic adventures, and let us know what you'd like to explore next. Stay curious.